Right, onward and upward. I've covered a lot of the network design in this too, so this won't take us too long to get through. And I'm not going to bore you with all these details because really it would just be me reading these off. So I don't want to do that. I just want to point out like what are these things and why are they important. So this is in talking about I've got a bigger network. Right. So you need to gather your network requirements, like how much area do I need to cover and how many connected devices am I going to cover in one single location. You have to go through, you have to think of everything that you can. And the reason why is because there's lots of systems out there. They're not showing you this. You can't just go out and say, well, I guess I'll get this Aruba system or I'll get this SonicWall system. Because they're not comparable. They're going to be different. And so you need to know how many devices. Do I need 400 devices connected to this one AP or 20 devices connected to it? And then you need to clearly identify the expectations. And that's not just to you, that's to other people. This is one of the things that IT people just don't do. And so you see this concept mentioned often that either they overpromise and they're, oh, it's going to be fantastic and this is going to be so good and it's not going to be a problem and all this is going to, and then it doesn't, right? It doesn't work the way that you said it did, and that's a problem. Or they read some article and they think, oh, this wireless is going to solve all of our issues and it's going to be just as good as wired because I read this article in People magazine that said it was. Right. And so you need to sit down and say, hey, this is what we're going to use, and this is really how well it's going to be. So if you're looking for it to be just like your wired connection, that's not going to happen. Or talk about, as it says, what kind of changes are going to happen over the next 10 years with this thing. And then you need to identify your design considerations. For instance, environmental considerations. Are there trees between you and the next building? Those things matter. Radio frequency gets obstructed. Physical RF obstructions that could disrupt a wireless radio signal. And so you really have to be aware of that. I'm going to give you an example of one of those things. All right, so I had this person, a student, a long time ago, and they got a job working for a local place. And they called me and they're like, I've got this temporary building that I need to get this Wi-Fi to, and I want to make sure that it's going to get there, and I just can't make it happen. It's not occurring. And so I asked him to describe what was going on, and then I told him what the problem was, and he called back a little while later, and the next day or so, and explained it again, and I told him what the problem was. And then so finally I went out there to the place where he was, because apparently he didn't believe me, right? So basically what's happening is that he's got his, and this was early on, so the wireless stuff was not super fantastic. So he's got his wireless access point, and it's in this building, and it's a brick building. And I'm being honest here, the temporary building that's been set up is only about 20 paces away. And so I'm standing in this building and I'm like, well, where's the other one? Yes, that's what you're trying to get to. And they're like, yeah, and it's on this end of the building, so it's not that far. I said, well, you got a metal door and a brick wall. And so your access point's not getting there. The only signal that's getting there is through that window. And he still didn't believe me. So I was like, okay, well, let's run a big long network cable to where we can't keep it, right? We can't keep it next to the window, but let's run a big long network cable. We'll put the access point next to the window. Boom, everything works. So I said, okay, let's put it back where it was and open the metal door. Boom, it works. So he really wasn't getting what I was saying, that indeed this stuff is not magic. A metal door will stop the signal from getting where it needs to go. A brick wall will disrupt the signal. The radio frequency is too small to get through that. And that's actually why I start with this point now, because the information doesn't really, describe it. And again, in some of their lectures, they kind of mention a few things, but they don't really tell you, hey, that's a big thing. So yeah, physical obstructions are a big deal. And trees, You might have it in one house, and all you got to do is just talk to the another house. You put it in the window. People are getting it fine in the wintertime, and now the tree's got leaves on it, and it disrupts the signal because of the water. And then, of course, dynamic RF obstructions. In other words, you've got it set too low, and you're trying to get across to the next house across the street, but traffic keeps going in the way. And then you have to think of future construction and where things are going to be, and where the RF interference is going to be, and where you can mount it. People will say, hey, can we get this out on the grass? And you have to look before you say, oh yeah, we can do that. You have to look and go, is there a pole we can put that on? Can we get power to that place? You have to think of all those things. So then you have to conduct an initial RF modeling, and that's actually using equipment that you can actually use with your own internal notebook radio. You just have to buy the software that'll make it work, or you can buy particular hardware, and it actually just will see what's out there, just like I was showing you, and it'll actually push the signal so you can see how it's going to work. And then perform your bandwidth planning, like how much bandwidth do you need, how many clients are going to be on that. A good example is EAC has really good, they provisioned it very well. Just about everywhere you go, you can get on that wireless network. It's kind of hard in the Math Science building because that building was not originally enclosed. And so the inside walls are brick, and that causes a problem. And I've been told that the dorms are the same way because the inside walls were brick. And so it's hard for stuff to get around in there. They weren't considered, they weren't talked to when all that stuff happened. But one of the things that happens to us is that we always, as faculty, meet in this one room, which is AP 118. And when we all get in there, that access point can't handle all of us. And so it'll kick people off. And so I'll lose my wireless connection, and I'll have to turn on my wireless card and turn it back on, and then it'll pick back up and kick somebody else off. So you have to plan ahead. And that's not a criticism of EA, because the honest truth is I wouldn't plan for 250 people to be in that room, right? That's a temporary situation, and that's not a normal situation. So, and then a site survey, which is actually where you go out and mount things where you think it's going to need to be. You document the concerns that you might have of whether or not you can get the appropriate, like they say, a wired backhaul. That's actually saying we're going to put this wireless access point up on a pole, and we're going to run a wire down it that's going to come into our equipment. That kind of, you have to think of how is all this going to connect? Is it going to all work out? And then plan for the Internet of Things. Other technologies that you didn't think about, like just all the stuff that can complicate things, like near field communications, and Z-Wave, that's a wireless communication protocol with home security automation, and those will use the same frequencies. That's the thing that they're saying. So you kind of have to plan ahead, like as that grows, is that going to cause us problems? Anyway, that's all there is in network design, and we'll move on to the next section.